Hello, welcome back to NMI. In this video, we're going to take a look at a very special operating system for the PC. It's an operating system that can fit a single floppy disk. Yeah, that is true. We're talking about an operating system that includes not only a GUI, a graphical user interface, but also some simple applications and even games. And it all fits in a single 1.44 megabyte floppy disk. Did I mention that it's written in assembly? Yes. So let's take a look. Here we have the web page for MenuetOS. It is located at MenuetOS.net. We can see here that Menuet has two versions. Menuet 64, which is licensed in a special license, and Menuet 32, which is licensed under GPL. So this is open source. It's interesting to see here that the authors claim that Menuet is not based on any other existing operating system, nor it has roots within Unix or POSIX standards. So Menuet is like its very own thing, right? The design goal was to remove the extra layers between different parts of an OS, which normally complicate programming and create bugs. Okay. So Menuet kernel is written in assembly. That is impressive, which gives speed advantage over systems written in other languages. For example, the GUI with transparency is calculated in the main x86-64 CPU. In our case, it's going to be the 32-bit version, right? But it's the same principle. Avoiding compatibility problems with graphics cards. Okay, yeah. Here they have the list of changes for the Menuet 64, which is currently in the 1.5 release, and it's pretty new release. It's the last update was in this couple months ago. But the 32-bit version of Menuet was last updated in 2019. So we can see here that they are not really developing the 32-bit version anymore, right? Another set of features here that we can see, it has preemptive multitasking with a 1000 Hertz scheduler, meaning 1 millisecond, right? Multiprocessor, multi-threading, Ring 3 protection. I'm not sure which of these features is also available on the 32-bit version, right? They also claim that it supports multiprocessor systems up to 32 CPUs. This is symmetric multiprocessor, right? It can go to up to 100,000 Hertz, the scheduler, which is pretty impressive. It has IDE editor assembler. It supports USB classes, storage printer, webcam, TV radio, USB 1.1 keyboard and mouse. It supports a TCP/IP stack with loopback and Ethernet drivers. I'm gonna say right away that I installed a network card in my Pavilion, but apparently that network card is not supported. It supports email, FTP, HTTP, VHS clients and FTP, MP3, HTTP servers. Yeah, this is also available on the 32-bit version. What else? Here we can see some more information. So you have a number of pages that you can navigate to get more information. In special, the system calls that we're going to take a look pretty soon, and example applications. So let's take a look at the system calls. This is for MenuetOS 64-bit. Oh, and it's slightly dated. This is for version 1.48. We saw that current version is 150, right? So let's go and see where is the here. So this is the 32-bit system calls table. We can see that it uses an interrupt, and you pass on EAX register the function number. So the API defines a number of function calls here. Define and draw window, put pixel and delay and other stuff. So here you can see how you populate, or which registers you populate on the function call, right? So we know that EAX has the function number, and then other registers are used for other parameters. Let's take a look something simple. A delay, for example. So AEX you're gonna set to 5, and then I said ABX? No, EAX, sorry. EAX you're gonna set to 5, and then EBX you're gonna set to the time that you want the delay, right? In hundreds of 100ths of seconds. So that's how the API works. What else we can see here? Oh, this is a quick history of MenuetOS. Basically, this is a project that started with a single person, Vil Turgenma. Don't know if I'm pronouncing his name correctly, and I apologize for that. And this started in the year 2000. Oh, okay, so 24 years ago. And the inspiration was the scripting language that were taking more and more CPU time, and they wanted to go into the opposite direction, right? Instead of writing code that takes a lot of CPU, they wanted to explore the other extreme programming things in assembly and using very little CPU, which is pretty cool. So let's take a look at the operating system itself.
Okay, so here we go. This is the floppy disk with the 32-bit image of MenuetOS. And for those who don't know, this is a 1.44 megabyte floppy disk, right? So the whole operating system fits inside this floppy disk, which is already pretty amazing. So this is the pavilion that I fixed on the other video. Now we're gonna use it to run this MenuetOS. So it's already running Windows. I'm gonna restart and let it load from the floppy disk. Okay. I think it's better this way. So yeah, here we are. Since the there's not enough space, I believe, for probing anything. There is this launch menu where we have to select a number of options. So here at first you have to select which graphics mode you're gonna run. So you have 600 by 480, 800 by 600, and so on. Let's start with 800 by 600. So option 2, use preset graphics mode, yes. Acceleration MTRR, yes. The mouse, I have a PS2 mouse here, 32 megs of RAM, and load from floppy. So we can hear the floppy. I find this updating floppy cache a little bit misleading, because when I read this, it sounds to me that this is kind of writing on the floppy, but I understand that in fact we are reading from the floppy, because that's the only thing that could be happening right now, right? There's no point in all these writes if we are loading the operating system. So we're approaching, okay, 90, 95. Here we go. Oh, graphics mode not supported by hardware. Okay. So 800 by 600 is not support. Let's try again. Try option 1. Here we go again. Now option 1. It's pretty low resolution, but okay. Graphic mode, yes. Acceleration, yes. PS2, 32 megs, load from floppy. Oh yeah, this one worked. Okay, here we are. It's pretty cool, right? So do we have, yeah, we have a menu here, lots of options, games. Okay, we have some games, 3D Maze, C4, Chess, Free Cell, Phoenix, Tetris. We have demos, graphics. Oh, there's a paint. Okay. Miss Clock Archive, CPU ID, scan code, CPU speed, calc, X3, MFAR. I have no idea of what is MFAR. Audio. I don't expect audio to be working because this machine doesn't really have a sound blaster, and if you watched the video where I installed Windows 95, you need to install like a driver, special driver, so it's not really compatible with a sound blaster. Internet, tools, okay, stack status, clients. Oh, there's a number of utilities already. So for the TCP/IP stack, even servers. Oh, that's amazing. What else? Coding. Okay, we have some examples, and FASM. FASM is the, I think it's the flat assembler. We're gonna take a look at it later. And here, system, CPU use, protection, debug, cache to FD, setup, processes, files. What is this setup? I think it's the same as this one. Let's see. Is this the same? Yeah, it's the same. Yeah, C Sound Blaster SB16 base 0x220. This is the same address that is loaded by the driver on Windows, but that is a special driver We can check it out later if it's working here. I don't think it's gonna work here. We also have some other options: system language, keyboard layout, Windows sound system base. Sound DMA channel 1. Okay, yeah, I think this is the right selection. Okay, what else okay, so let's try, since we're talking audio, there are some options here. Mixer, what is the mixer? Main. Okay, wave. Now let's try to play something. Audio, wave player. Oh, but it's trying to play from HD. Is it gonna play? I don't think so. Yeah, I don't think it's playing. No. Can we load something else? This menu is a little bit odd because you don't know which option you're selecting. Yeah, nothing seems to work. Save doesn't work. Okay, quit works. Yeah, okay, that's a bit odd, but I am not sure audio is working. Maybe it is. What else? CPU ID. Oh, cool. So this is 233 megahertz. Yeah, right. P55C with MMX. Yes, this is a Pentium MMX. Oh, very interesting. Okay. CPU speed. Oh, this is measuring the clock speed. Okay. There's a calculator. Oh yeah, cool. All of this in this floppy disk. It's amazing, right? It's a lot of applications here already. Let me see system. CPU use. Oh, okay. Oh, there's one fact, and maybe we can demonstrate with this window here. This is all rendered by software, so there's mostly no acceleration. So if we move this window, we should, oh yeah, see the CPU usage going very high. Now if I stop, the CPU usage goes down. Yeah, okay, that is very interesting. What else we have here in system? Set up processes. Oh, it's not working. Oh yeah, there is a bug there. But okay, now we can see. Okay, so here we can see all the processes that are running. Interesting, the icons. The icons are also processes. Yeah, they have their own PID. Yeah, that is very interesting. And the OS idle is using most of the CPU. That's good. Let's try some games. What is this 3D maze? Oh, okay. Also, I can navigate with the mouse. That's not super fast, but again, this is all software rendered. So It's okay. What else we have here? What is C4? Oh, I think this is connect 4. Okay. The mouse is super sensitive, maybe too much. We have chess. Oh, this is a client. Oh, so this is a network chess. Yeah, see, connect, logging. Oh, that's cool. Okay. What else? HD. So I don't have anything installed to the HD, but oh, even DOSBox it supports. That's pretty cool. Quake, Doom, yeah. Free Cell, new game. Yeah, that's oh, yeah. That's nice. Again, a lot of stuff, cool stuff. This Phoenix. Oh, this is shooting up. Yep. Oh yeah. Okay. I'm not gonna play this, but yeah, another game. Not super fast. And finally, there is also Tetris. Oh, I don't know the control. Oh, okay. Here. Oh, okay. Okay, I'm not gonna play this. It's very nice. There's a lot, honestly. And that single floppy image. There is paint. Oh, another issue. Yeah. Yeah, okay, that's just a painting program. The colors here are not showing up properly. Yeah, but okay. Okay, there's a bunch of stuff here. Some of them we already saw. Now I want to take a look at coding. RT data, thread, example. Let's take a look at this thread. This example create. Oh, okay, so every time we press this button we create a new thread. Yeah. Okay, now let's take a look at something. If we run process here, can we run process? Yeah. So we have the threads there. Now these things here are buttons, and maybe you can, oh yeah, terminate them by pressing them. Oh yeah, one is gone. Now the other is gone, and now, oh yeah, cool. Okay, what else we have in coding? E30. Let's take a look at this example. Example application, system functions are gray. Contents, no, nothing works. File open doesn't work. Quit, yeah, quit usually works. What is this text editor? Oh, another bug here. Yeah, so this is an M32 example application compiled with FASM for Menuet. Okay, header, call draw window. Okay, is this here? Yeah, draw window is here. X EAX. Okay. Yeah, it's a long time I don't see x86 assembly. So here we have the menu structure. Oh, and that sentence. Oh yeah, the window label and the text. Okay, so we can make. Oh, it doesn't work. If I click here, the cursor does not go there. Okay, just for fun, let's try something. NMI test application, and oh yeah, it doesn't work, so I need to system in shock. Yeah, I'm a big fan of System Shock. Okay, so file, save. Is it gonna work? No, save here. I don't know if it's saved. Let's load it again and see. Coding, text. Oh. Okay. Yeah, it's saved. NMI test application. Okay. So now let's use FOSM. Flat assembler. Yep. So, oh, example ASM is already here, and it's gonna output to example. So start compile. Oh, okay, fast. Only 323 bytes. Now run. Oh yeah, see? NMI test application. System in shock. Cool. And what else we have? Internet. Yeah, I don't think tools stack. Yeah, I don't think I added a network card, a PCI network card, but I'm not sure it was detected. I don't think so. So I'm not sure I'm gonna be able to try anything with internet connection today. What is the status? Oh yeah, see, Ethernet card status. There's nothing there. Yeah, so that tells me that it's not working, which is fine. I think that was a good first view of MenuetOS 32.
Menuet is pretty cool for an operating system written completely in assembly, isn't it? I am really impressed. It's not like it's super useful, but it's pretty interesting. Anyway, I hope you enjoyed this video, and if you did, please consider subscribing to NMI, and see you next time. Bye!